And that's also a walkthrough an example of selective repeat, just like we did one for go back in. So that example in go back in is actually harder to analyze. This one, on the other hand, relatively easy. Now it looks very much like the example in go back in. So window size 4, and we start from base 0 and the next seek number 0. Getting a call from above? Yeah, because the next seek is less than base plus 4. Therefore, we generate packet 0 and send it out. And we go on until we hit next C equals 4. And that is not smaller than 0 plus 4 anymore, so we wait. All right. Now, over at the receiver side, scenario similar, receiving packet 0, but the receiver's action different. Okay, for packet 0, we send individual ACK 0. Receiving packet 1, we send individual ACK 1. Well, not getting packet 2, but we'll be getting packet 3. And out of order, so we buffer and send individual ACK packet, ACK 3. So ACK 1, ACK 0, ACK 1, and ACK 3 will go back to the sender. Now, sender, upon generating packet 0, packet 1, packet 2, and packet 3 will all start the timer individually. So T0, T1, T2, and T3 will all be ticking, no worries. Okay. Now, ACK 0 now comes back to the sender. Sender receiving ACK 0 will do what? Clear packet 0. So that packet will turn green. All right. Is it in sequence? Yes. So we advance window. Yeah. Advance window by 1 to the next unacked packet. Upon receiving packet 1, also, yeah, advance sequence by 1 because it's in sequence. And hey, so base is changed to 1 and then to 2. So that allows us to send packets more, right? So 4 is generated, 5 is generated, and they're being sent out. Well, packet 2 did not get acknowledgement, but we get what? ACK for 3. All right. So what do we do there? Yes, we actually release packet 3. So we turn that into green. But hey, packet 2 there is still yellow. All right, so this green packet, packet 3, is not the smallest unacked packet. So we cannot advance the window size further. We cannot advance the send window further or the base further. All right, so cannot be sending more. So still wait here. Okay, so this part of go back in and selective repeat similar. All right. But now, look, packet 4 and 5 will go to the receiver. Receiver here receiving 4, out of order again, buffer, send ACK 4. Packet 5, buffer again, send ACK 5. And those will go back. Here, timer for 4, timer for 5 will be fired because there's one timer for individual packets. Okay. So finally at this time point, yeah, timer for 2 finally expires, and therefore we resend packet 2. Packet 2 goes out, received. Finally, this is the smallest unacked packet, and all the packets subsequenting packet 2, 3, 4, 5 can be passed up, okay, in sequence to the application layer, and we send back ACK for 2. All right. So simpler. The last bit of selective repeat is this. Let me show you this case. There are 2 scenarios, okay, but from the reviewer's point of view, they will actually look the same, right? And this is due to the fact that the sequence number here, the sequence number space, and the window size there is not set in a way that we could tell individual packets apart. Those who are sent earlier versus those who are sent recently. Okay, so the example goes, sequence number, only 2 bits, so there are only 4 different numbers. Window size, 3. All right. So the selective repeat sender side will look like this. Well, the window size is 3, so we can only send 3 packets back to back of each other. So packet 0, packet 1, packet 2 goes out. Receiver here receiving 0, 1, and 2. They will then send back Act 0, Act 1, and Act 2. So Act 0 here arrives back at the sender first. And this is in sequence, so we advance the send base. And we generate yet another packet to go. All right. And the next act, that's going to advance the send base further to 2. All right. And we generate yet another packet to send. And the next one will be what? Yeah, carrying sequence number 0. Now, if packet number 3 did not arrive at the receiver, all right, receiver here will see, all right, I got the packet 0. And you know what? Within my window, I am indeed expecting someone carrying sequence number 0. So this one will be what? Buffered. And an ACK of 0 being sent back to the sender, isn't it? All right. So that seems to be fine. Yeah, this is the no problem case. Wait until you see the next one. Here's the next one. Same scenario, window size only 3, and we have sequence numbers. There are only 4 of them. So we send packet 0, 1, and 2 out. Receiver here generates Act 0, Act 1, and Act 2 back. But unfortunately, all of them are lost. So timeout is going to happen and retransmit packet 0. This packet 0 will go, and receiver here will say, hey, you know what? I'm expecting packet 0. It's within the receive window. So buffer and send back ACK for 0. Sounds familiar, isn't it? Because that's exactly what's being done here in the first scenario. So from the receiver's point of view, identical. Also, buffer the packet and send back ACK 0. But the thing is this, at the sender side, you see, this packet 0 is a retransmission of the first packet 0. But this packet 0 here is actually the second packet 0, no longer the original, the first packet 0. All right. So if packet 3 here arrived at the sender, this sender is going to what? Clear that gap and pass 0 up to the application layer. Before that, pass, of course, packet 3's bits into the application layer. So 3 and 0's data bits will go to the application layer. But look here. This is packet 0. When packet 3 finally comes here, it's going to clear and send packet 3's bits as well as this retransmission 0's bits up to the what? The application layer. So you get unwanted duplicates. So you do have a situation here. From a receiver's point of view, it actually sees no differences in the two scenarios. You get duplicate data in the end in case B. So we need to be careful here to prevent packet 0 here and packet 0 here obviously are 2 different packets, but being confused as the same packet. Okay, so according to case A, will actually pass packet 0, these bits again, to the application layer. Not good. Right? So in order to tell this packet 0 and this packet 0 apart, we have to think, what is the worst case? Okay? Can we use a sequence number such that we will not be confusing this packet from this packet? Okay, so a new packet should be farther away, should be carrying a sequence number that's farther away from an earlier packet. And no worries, if you look at this, case number 2, case B here, is already the worst case that I'm illustrating. So in this case, we're seeing that the receiver is advancing the receiving window one after another. So receiver is saying, hey, everything is okay, let's move on. But sending side here, not getting any eggs back, hesitates and waits and waits and waits and not moving. So you have one end moving really fast and the other end staying. Okay? So you see in the end, the worst case is what? The sending window never really moved, but the receiving window moved the entire end. All right? So they are actually end apart. If you want to make sure that none of the packets still in the sending window will be confused with the packets in the receiving window, what do you need to do? Isn't it obvious? The sequence number, make sure that the space is larger than 2 window sides, right? Then, hey, packet sequence 1 will never appear again in the next window, in the receiver's window. All right, so you would never have the trouble of confusing an old packet from a new packet. And that is why the sequence number space here needs to be larger or equal to 2 times the window size.